Well, welcome everyone to our second talk today. The theme is, as you know, enterprise knowledge graphs and how they can be used towards knowledge economy. Our second talk is given by Jans Aasman, who's the CEO and founder of Franz, who is also our sponsor today, our gold sponsor. And Jans is going to talk about the future of AI in the enterprise and how entity-driven knowledge graphs can be used for data-centric organizations. I could say a lot about his background and where he's coming from. He's one of the most prominent people in this space, but rather I can let him speak for himself and just minimize the time I'll take. So, Jans, the floor is yours.
Okay, and then a quick question, George. Do I turn off my camera?
I think it's already on. At least I can see you normally, so I'm guessing everyone else can as well.
But do you want me to turn it off? That's the question.
It's up to you. I guess you have a slide deck that you're going to use to present.
Yeah. So it's going to be in the way. Okay, all right. I'll.
No need to turn off the camera.
Okay. Then I'll start now. All right.
Mm-hmm.
1 second. Okay. Setting a timer here. All right. Let me go to my screen, and you have to tell me if you see my screen. Do you see my screen right now? George, do you see my screen?
Yes, it's good.
Okay. Perfect. Okay. Okay. Well, welcome everyone. So I'm going to talk this morning. Well, sorry, it's morning.
So nice.
Here's the morning here in California. I'm going to talk about the future of AI in the enterprise, and I'm going to talk specifically about what we call entity event knowledge graphs for data-centric organizations. So quick about our company. We're a private company, probably one of the few graph database companies, not venture funded, headquartered in California, and our main product is a Lego graph, a semantic graph database, and we build knowledge graphs for our customers, and we have a long history in artificial intelligence complexity. So that's all I'm going to say about our company. And then the key message for today, is so you in the audience, and you're probably already building a knowledge graph, or you want to build a knowledge graph. I'm not trying to convince you that you need to build a knowledge graph. You're probably here because you're interested. Now, one of the things that we saw is that most people, when they start, they basically copy the complexity of their relational databases in their silos, and they copy it in a knowledge graph, and then it's still hard to deal with the data. So our key message is that you can manage the complexity of all the data that you have by using our entity event model, so that you can make it at least 2 orders of magnitude easier to understand your data, or do queries and feature extraction for machine learning, or retrieve a 360 view of your core entity in just a few milliseconds. Now, I know I haven't explained what an entity event model is, but I'm going to do that in a number of use cases that we've done over the years. And then I hope it becomes clear what we actually mean by this entity event model. First, we're going to talk about the telecom use space, where we looked at how you can build a knowledge graph for CRM. And that's where we first got into this issue of entity events. And then we've been working for the last 4 years with a big hospital in New York called Einstein Medical College in the Montefiore Hospital, where we really deeply went into how you create entity event models. And now we're actually using it also in a call center in Atlanta, but we do many other projects in industry. But these are the main use cases I want to talk about. So what have all these clients in common? Well, the first thing is they all believe in the dream of a data-centric organization. So in most companies, there's a business problem, so you need a new application. So you get your new application, you build a database to support it, and then you link it to everything else in the company, and you have created another silo. People that dream of the data-centric organization believe that you should have only one data platform and put all your applications on top. So applications come and go, but your data stays mostly the same. Yeah. The other realization is, what people have in common is the realization that 95% of all silo data is event data around one or two core entities. Yeah. So in a hospital it would be a patient, and in telecom it's the customer, in the bank it's the customer. Sometimes it can be a product. But because you see that all your data is actually events, yeah, you can actually also structure your data as an event objects, and that makes your life many, many times easier. Yeah. And then finally, what all these clients have in common is that every knowledge graph we see by now uses natural language processing to get an insight in what actually happens in the unstructured text. And what they do all is to try to start, well, they build learning knowledge graph by adding machine learning and feeding the results of machine learning back into the knowledge graph. So you get learning systems. So that's what they have in common. So let's start with the first use case where we developed an entity event model. Yeah, so we were with this telecom company that wanted to build a CRM system, and they wanted something, yeah, that, so in general, what happens is customers call in with problems, yeah, and then the poor agent has to look in at least 10 systems to figure out what the problem might be, and then finally come up with a solution. And it might take multiple calls to get a solution. So they wanted a system that already anticipates what the user is calling about, and then automates access to the required information to make it easy for the agent to find the diagnosis and the information, and even guide the agent with how to make a decision, how to help the customer. Yeah, and in practice, the system really eliminates system and agent diagnosis time, and it makes the handling of calls way, way, way more consistent. And both the agent and the customer were way more happy with that particular system. Yeah, and so this knowledge graph, yeah, can do many, many things. Yeah, when I call the call center, it already knows the 3 most likely reasons why Jans Aasman is calling the call center. Maybe my bill is way too high suddenly, or I lose connections too often, or I don't know how to set notifications. Yeah, they figured that out already. They know the last 10 things that happened to me. So when I call, they already have a list of those. They know if I'm a really good payer, and so they help me instantly, or I'm a really bad payer, and you get to the back of the line. Or they also want to know if I call, is this guy on the fence of switching to another? Let me help him as soon as possible. Yeah. Or you can do many other things, like do social network analytics on your data, or even know where your customers are daily, and then do interesting things with that. So, but if you want to build a system like that, the old-fashioned approaches like business intelligence don't help you at all. I mean, a business intelligence system can tell you all about an average customer, but only a knowledge graph can tell you about the individual. And so my customer wanted this 360 view of everything with respect to the customer. And the people that we were working with were really incredibly experienced Oracle users. Yeah, they had been doing Oracle in telecom for 20 years. So they knew what they were doing, and they knew that building a new relational database on top of all the other databases was a no-no. And so they started by doing an experiment, because they got this idea that they wanted to use a graph, and they started building these graphs from that data, but they quickly realized that they were actually copying the complexity of the relational databases into the knowledge graph, into their graph. So that didn't help them at all. So then we got to this crucial insight that if you look at all the data, you squint, look at all your data, then you actually see that 95% of all data is events data. Yeah, it's people making phone calls, people paying a bill or not paying a bill, people activating a phone, people calling to the call center to complain about something, but everything is an event. So the idea was, then why don't we just make one event object, yeah, that we use for everything, where an event object is just a simple thing with a type, like a call to the call center. There's always a start time, sometimes an end time, sometimes location, and then just a few additional key value pairs that describe the event. But the shape of the data becomes incredibly uniform. And so we have the system where you can have the all these different source systems, relational databases, email, other CRM systems, network information, and you turn everything into a JSON object that goes into this object here. And then every time when there is an event for a particular customer, the decision engine will call up everything they have about that customer from the database, put it in memory, run a bunch of inference rules, even do a Bayesian belief network to predict what actually might happen with the customer, then put all the data back and maybe do some actions. And then, because they have all of it, they can take all these events and start creating business concepts where the business people can do something with. So this person, John Smith, might have a churn propensity of 18%. He's got this particular plan, and you can see to what extent he fits with the plan, how often he had dropped calls. Anyway, this is data that is important to the business people. So that was the first time that we really dealt with entity events, and it worked out incredibly well. So then 4 years ago, we started working with a big hospital in the Bronx called Montefiore, where we also created one knowledge graph to do any type of analytics that you can think of. And it's heavily sponsored by Intel and now also by HP, because they think it's a great effort to have something like this start within a hospital itself. So not an external AI company that wants to do something interesting with hospital data, but actually this is something that is done in the core of the hospital. And so we have this one knowledge graph, that you can use for any type of analytics. We started in 2017 with a respiratory failure model. I'll say a few words about it in a minute. That got their attention of management. This was still not very much a core process. But then they could also use the exactly same data shape and data model with all these events to do sepsis detection. And they could take a team of about 20 people and no longer use them for going through records to see if a patient might have gotten sepsis, but actually they used the same data structure. And in 3 weeks' time, they had an application that is way better than what human beings can do. But the same data structure can also be used to, say, do outpatient appointments, or regular business intelligence. So this has been tried. This is something we've been doing now for several years. And well, let me tell you more about the data, what we do underneath all of this. So, but let me first talk about one use case. So the first use case that went in production was this predictive model for respiratory failure on top of our knowledge graph, where this model can detect respiratory failure up to 48 hours before the event, way faster than doctor and nurses. And this model uses 46 complex variables, whereas a doctor doesn't have time to look more than 3 or 4 variables. And these variables are pretty complex, like give me the largest difference between the value of serum calcium level and the midpoint 9.5 in the range of 0 to 20 for the last 24 hours. So, I mean, if you're a doctor, so what you see here is scatter plots for each, 16 of the 48 variables that we use in the model. And the blue one is the mortality, the chance of mortality. And here's the data elements. And so you see for each kind of data, like for the heart rate, or age, or weight, or glucose levels, or sodium levels, there's a different shape. So no human being can put it all together, but an AI can easily do this. Anyway, so this is in production to the extent that's even used in the hospital. Then this is a typical Epic screen. The biggest hospital enterprise system. And now when our random forest model says, hey, the value is too high, then it will actually ask a human being to make a decision. Like the system says, hey, you're at risk. And then the doctor can say, well, it's not my patient, or I disagree, or whatever else the doctor might decide. But anyway, so this system is in production. So if you look at this, you could look at it as an effort to create a real mature data fabric in a hospital, where you really want to be at the top, where you can use one platform for any kind of analytics, where you can do personalized medicine, prescriptive analytics, true cost of care, But of course, you always start with your silos, and if you're rich enough, you can pay for an enterprise data warehouse with 4,000 tables, 20,000 columns. But no one in his right mind will ever do data analytics on that. So people build data marts. Yeah, but even that was too complicated. So here we also, just like with the telecom use case, came up with this idea that we need to use the entity event model. Yeah, so you can look at all these databases in the hospital and kind of see that it's actually all events. Yeah, a person checks in, checks out, gets a test, does a procedure, gets a medication administration, sensor reading for vital sign, an invoice, a bill payment. Yeah, putting this in relational tables is just pure madness, but making it simple by putting everything into event objects and hang it off the core entity, which is the patient, makes it suddenly way easier to understand your data and do queries with your data. Another point we did, this is also important for every knowledge graph that we've built, is you need to have a good terminology system. And especially in healthcare, it's incredibly important that you use the same name for the same thing. So the hospital worked on a combination of 180 medical and life science vocabularies taxonomies, and all integrated in one. And then, it all goes together with this event model, and I'll show you that in a minute how that works. And then, because the ultimate model in the knowledge graph is so simple, the ETL becomes also very simple. Yeah, it becomes extremely easy to take any value in any of your silos and map it to a event with its correct attribute, and you're in business. And then in this knowledge graph, you also want to use external data sources. Yeah, and because this is all semantic technology, yeah, it becomes extremely easy to put in a PubMed database or an adverse reaction database or a weather database or a census database to see if people live in a poor or in a rich area, etc. And then this is so much data that you have to store it in a distributed semantic graph database. Yeah, so we've done that. And then ultimately, we did all of this so that we could do our data science on top of all the data. Yeah, so we now have a whole slew of things when it comes to data science. Most importantly, a declarative semantic description of data frames to automate retrieval of features from graph. So think of it this way. Instead of all these data scientists having to write Sparkle queries to get features out of the knowledge graph, we created a system where you just say in Python can specify the feature factor that you need for your machine learning, but just creating a bunch of Python dictionaries or JSON objects where you specify the name of the variable, some other parameters. Yeah, give that to this data frame system, and it will automatically do the Sparkle queries for you. Yeah. So anyway, that is the maturity stack. And so continuing, so I talked about that everything rests on that entity event model. So, and the core features are entities and events are represented as hierarchical trees. Yeah, but we also group entities and events together. So for people familiar with semantic technology, so think of it, you have a core entity with events and sub-events attached, so you get a tree, yeah? But what we make sure of is that the fourth element of every tuple in this tree has the patient identifier. So that because of our indexing technology, we can easily say, hey, give me all the tuples or all the knowledge you have about this one patient. It takes a few milliseconds and you get everything. You have a complete 360 view of this particular patient. And of course, all of this is terminated into a knowledge base. So how does it look like? Yeah, this is a picture of our tool called Graph, where you see you have a patient, a thing of type person. It has an outpatient encounter. So this is an event. So this is the core entity. This is an event of type outpatient encounter that happened at this particular time. This event had a sub-event of patient diagnoses, which was allergy to peanuts, which is an ICD-9, ICD-10 code, which is then mapped to an object that maps to one of the 180 terminology systems. So everything to the right here is terminology, where you see that allergy to peanuts maps to SNOMED allergy to peanuts, which is a child of allergy to legumes, which is a child of food allergy, etc., etc. So if I want to find all the people with allergy to peanuts, just go back through the graph, find allergy to peanuts, and find a bunch of people. Or I can say, give me all people with food allergy. Well, then it goes back here and it find 400 ICD-9 or ICD-10 codes related to food allergies, and they get way, way, way more people, as you can imagine. Yeah. So to summarize, we have a core entity here, a patient. Then we have all the events that happen, and then we have the taxonomy system. And this is the same pattern in every of the entity event knowledge graphs: a core entity, an event graph, and then the knowledge bases. Yeah. So now let's talk about why this is so cool. Well, to begin with, say you want to do a query, give me all the patients that had gallbladder calculus after the year 2010. Well, in our graph system, we can actually visually write queries like, okay, give me a person that has an encounter with a diagnosis that corresponds to a concept that matches gallbladder calculus, where the encounter happened after this particular time. I push a button, it creates automatically this Sparkle query, and that's it. In SQL, this is part 1 of 3. Yeah, so this is what you have to do in SQL, and it takes you hours, maybe days, to write this query and debug. Yeah. So again, it becomes, I can take any one of this audience probably and train them in 2 hours to understand our data model. Yeah, and start doing queries with our tool Graph that lets you visually create queries. Whereas if I had to take you to the enterprise data warehouse for the SQL query, I wouldn't even know where to begin. It would take me weeks to get you going. Yeah. Anyway, so the other thing I talked about is how easy it is to get the 360 overview. Yeah. So for the people in the audience that can read Sparkle, this just says, well, select everything where the fourth element of every triple is this patient identifier, and then give me all the triples, and I get all the triples. Unfortunately, developers really didn't like it because now they get 1 million triples in their Java application, and that makes it still hard to deal with. So now we can also in Python say, okay, give me the patient, yeah, that has this identifier, and I get a beautifully formatted JSON object that also has all the data available. Yeah, and now an app developer can easily start working with it. I already talked about that ETL becomes a lot easier, and again, it's very important. People always think, oh, I have built a knowledge graph. That's a huge Big Bang thing. No, it's not. You choose a simple app to begin with, and then you just take the most important events that you need, yeah, and you start building. And you never have to change this event. The shape of the event stays the same, but if you get another use case, you need a few more events from your database, but you just add events. You never change events, if that makes any sense. Yeah. Then for us, it's important that for every element in our tree, we always can find back where the data came from. So 75% in our knowledge graph is actually provenance data that points back to the database, the table, and the column where the data came from, and even the date and the procedures that were used to create this data. And then we have something that I can't talk about today too much, but we can actually also attach a key value pairs to every triple in our system that we can use to write security filters. So we have by far the most secure system in the world to offer kind of what Oracle calls cell level security. We can do triple level security. So we can write security filters for every single for triples, and protect every triple in a different way. So that when I do queries, I can put also some user attributes on the same on the user, and like this triple has a security level 8. Well, this user has security level 2. This is what the application layer added, and so this user cannot see these triples. I mean, I'm going too fast for this one. I apologize. Yeah. And then one of the things we do, as I said, we have machine learning, and then we put results of data back into the graph. So, for example, I could do a query like, so I have here a database with literally, this is the terminology system you have, plus some statistical information that we got from the real data. So I can now ask, okay, if I have allergy to peanuts, what are the top 5 other things that I might have? And I can run this as a query, and you see it automatically creates a Sparkle query. I get a table with results. Yeah, I can see that if I have peanut allergy, then dermatitis due to food taken internally is 210 times higher than normal. So then I can turn this into a visual graph. Yeah? And I could even say, are there more statistical relationships between these things here? And I can do this, and I can choose a predicate to look at this, and I can start asking for the shortest path between every pair. Yeah. And so I can see for every disease and for every symptom in the systems, the most related systems. Yeah? So, and that's just because we did machine learning and analytics on top of all the data that we have, and then we turn it back into the graph. And so now we have a learning system where we can actually help the doctor with, oh, if this person has this and this, he also might get this and that. That's a very quick demo, and again, I apologize, it went so fast. And then the entity event model has one more really important advantage, and that is you can do horizontal scaling through sharding. Because an entity event this entity event model creates entity event trees that are logically grouped because the fourth element is this patient identifier. We actually can shard, for example, on patient ID. Yeah. So we created this system where entity events go into shards with entity ID as the shard key, and then we federate every shard with non-shardable knowledge bases. Yeah? So 95% of our data can be sharded. 5% is just knowledge about healthcare, about department, about the doctors, about other things. And we put that into non-shardable databases, and then we federate the shards with these non-federated shards. A lot of patents around this. Yeah. And so now we have a system where a user can take a Sparkle query. We strip off the aggregate parts of the Sparkle query. We send the same Sparkle query to every shard in the system, yeah, where the shards are federated with these knowledge bases. We get the results back, then we do our aggregation. And so this allows you to deal literally with hundreds of billions of triples. Yeah. Okay, well, enough about that. And then finally, let me talk about the third use case, which is an entity event knowledge graph in an intelligent call center, yeah, where the knowledge graph serves as the history of every customer you ever tried to sell to. Yeah, so you have a call center. Call center sells stuff for other big clients, yeah, and you sell to ultimately to customers, where you you try to set up an appointment for your client. Well, so that is the first role of this knowledge graph. And then the other thing is the knowledge graphs help with real-time decision support. So we listen in to the conversations between agents and customers. We use speech technology and natural language processing, and we can detect all kinds of things while we're talking. Let me talk about it in a second. So we do this for a company called N3, was just acquired by Accenture. And this N3 works for all the big guys here, selling mostly cloud-based services, many other things. Yeah. And then here is the entity event tree for the intelligent call center that we built. Again, you might remember from before, there's a core entity, which in our case is the customers you're trying to sell to. And then and here's the events. Well, part of the event is that this is a contact person that your call center agent is talking to. Yeah, and this guy might have first worked for the CVS in Oakland and then later worked for Acme Bread, or vice versa. Yeah, so this is already an event. Yeah, people working for a company is an event. And here is one of the call center agents that is talking to this person. And then here are the core events. Yeah, this is your call center agents make voice calls, or they send emails, or they chat on a website. So this is where 95% of all the events are. And then here we have the knowledge bases of the campaign you're doing for Microsoft, all the names and the relationship between clients, the taxonomies that you need for products, et cetera, et cetera. So this is, again, the same kind of system, core entities, events, and knowledge bases. Yeah, but this in itself is already billions of triples. But actually, where the real mystery is and where all the gold is in what actually happens in the email exchanges between customers and agents, and the voice calls between customers and agents. Yeah, so we did a lot of work in the last 2 or 3 years to actually apply speech technology and machine learning to just this little part so that we can help call center agents in real time. Yeah. So we want to know where the agent is in the sales cycle. Did she move the process forward to get to a sale? Yeah. Did the person talk about budget, authority, need, and maybe a timeline? Yeah. Should I correct for open or closed questions? Maybe the agent asked too many closed questions and I can put it on the screen. Hey, ask some open questions. Does the agent talk mostly about product categories, or should she talk about the products that the customer actually can buy, the sellable products? Yeah? And what should the agent do when the customer starts talking about the competitor? Yeah, so you need to have battle cards in real time, so you can help the call center agents with arguments against your competitor. And well, if you talk to to a customer, it's very important that you know about the industry, the kind of person you're talking, and what the use case of the customer is. So again, in real time, we can help with that, etc., etc. And so we have this system, and I'm going to spend only a few minutes on it because we're running out of time. But we have this system where we can take speech recognition, we can any kind of documents and use Apache Tika, or we can take plain text and we put it in our ingest engine, goes into the knowledge graph, yeah, and it's just plain simple text. But we spend a lot of time on building taxonomies. Yeah, for example, this is for a company called Cisco, where we have all kinds of information about the products you're trying to sell, and we need to be able to recognize the products they talked about or wrote about. Yeah, and so we take the taxonomy, put it into the graph, and then take the taxonomy in the text, put it into our entity extractor, and now we have entities attached to the plain text we had. We can do the same thing for sentiment analysis. So we can say, oh, was this a happy talk? Was the customer angry? You also want to know the nature of a call. What was the nature? Was this an immediate sale, or did the customer want to replace his existing system? So we have label services, automated labeling, or human beings doing the labeling. And then we give it to our text classifier, and we even store our text classifiers directly into our knowledge graph. Yeah. And then we compute statistical correlations between entities in the text that we recognized. Yeah, because you want to, and you can use that to build recommendation engines. And then ultimately you can search in this database using semantic search, but I want to keep this short because I want to get to the end. With this particular knowledge graph, we can apply all kinds of analytical tools to give the managers at N3 insights. We can do ad hoc queries to figure things out. And we use the knowledge graph to give real-time decision support to the agents. So, okay, I went really fast through this, and I apologize if you couldn't keep up, but there will be a video of this, so you can see it in slow motion, or the slides will be available. So, but here's the point. So you want to try this. Well, we help people do a proof of concept with the entity event model. Yeah, and again, what I said, you don't need a big bang. You can just start with the simple use case, with the simple model of existing events that you have in your particular industry, yeah, and build a simple model. Because you can guarantee that doing more complicated use cases only means adding more events, but don't change the shape of your data. Yeah, and we've seen that in just 1, 2, 3 months, we can already show you the core benefits of the entity event model. And then finally summarizing, so we have proven now to several of our biggest customers that we make it way, way easier to understand very, very complex data. We make it very easy to do queries and feature extraction, and make it easy to get a 360 view of your entities. Yeah, and if you don't believe us, we'll help you with your first POC to make an entity event model for your data. Okay, so that was my talk for today, and let's see if there's any questions.
Well, thank you. Thanks a lot. Very interesting talk. And actually, case in point, you got a ton of questions. The only issue is that we're so much out of time that we maybe would have time for one question, and it wouldn't be fair to choose one. I think we have at least 10. So what we're going to do is we're going to collect all of the questions, and then we're going to share with you offline, and then we're going to get back to the people who asked them offline, because we have to wrap up, because we have another talk in a couple of minutes, actually. So thanks again. Thank you for your talk, and we'll address all the questions offline. So
you said you had one question, or just want to?
We have many of them, actually, like 10, 12, 15. It wouldn't be possible to answer them all. So what we're going to do, we have logged all of the questions, and so we're going to address them to you and get back to the people who asked them offline.
All right. Okay.
Okay, so that's it. Thank you very much. You can see the link for the next talk coming up in the chat. We're closing this one, and see you in a bit. Thank you, Jans.
Okay. Bye-bye.